Alright, and welcome to the continuation of this classifying statements. We know what tautologous means are all true, no matter what the truth value of the parts. Self-contradicting means it's always going to be false, and contingent means the truth value of the parts will determine the truth value of the overall statement. It'll be contingent. And what we saw was an example of each, just real simple samples. But we're going to get into something a little bit more difficult now. We say that basically 2 to the power of n is the number of lines you will need in doing your truth table, meaning how deep you're going to have to make it. So far we've just been doing 2 because we've only had one variable. But n equals the number of unique letters. So 2 to the power of n is, 2 to the power of 1 is 2. 2 to the power of 2 is 2 times 2, which is 4. Okay, so in this one, there are 2 unique variables. So it would be 2 to the power of 2. And so we would say that equals 2 times 2, which equals 4 lines, is what you're going to need. Now, on the other hand, if you have down here and you have A wedge, B wedge, C, that's a 3. Sorry, we got to get this back up here. And that means it's 2 times 2 times 2, which is 8. Which means we need 8 lines in order to get every possible truth value for the parts. And then if you come down here, A wedge B, wedge C, wedge D, with parentheses around it, A and B and C and D, that's 4 unique variables, which means you have to go 2 times 2 times 2, which means you'll need 16 lines. And if you had a 5th one, if you had a wedge E in there, it would be 5, which would be 2 times 2 times 2 times 2, which would be 32. And you could go on 6 variables or 20 variables. If you get 20 variables, it would be 2 times 2 times 2 times 2 times 2 to the power of 20, and you would have a lot of lines. So what happens here is we can sort of think about this, if we could put this in a chart, if you have the letter A, that means it could be true or it could be false. Those are all your possibilities, right? Now at the same time, you have this second argument, which is A wedge B, and A wedge B is 2 unique variables. So in this case, you're going to need to have a box that will have 4 lines. And the reason why? Because you have A wedge B, and A could be true, at the same time B is true. A could be false, or I'm sorry, A could be true, at the same time B is false. At the same time, A could be false, at the same time B is true, and at the same time A could be false while B is false. In this case, B is both false, and it's also false while it's true while it's false, and it's true while it's true, while they're both true. And we can just go down here then and assign these, and you would get the truth value of being a contingent argument, right? Because you have an F. They're not all true. But then you come along here and you have A wedge B, wedge C, wedge D, right? Now in this case, we're going to need 8 lines. So we can go ahead and insert ourselves a table. And you've got 1, 2, 3, 4, 5. We're going to need to be 5 wide. And we're going to need it to be one more. Well, that's fine. We're not going to be able to get it all the way across. We're going to need that to be, I want to put parentheses A, wedge, B, close parentheses, wedge, C. So in this case, what we know is we know A could be true, and what we always say is it's going to be 8 lines, so we want A to be true on 4 lines. Let's see if I can insert a line. So in this case, A can be true 4 times, and it can be false 4 times. And I always say, if you have 8 lines, then do true, 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 4 trues, and then 4 falses. Then come over to B and do 2 trues, and and 2 falses. So previously you had 4 trues and 4 falses. So you do it now in half. So you do 2 trues, 2 falses, but then come along and do that again. And then you come over to the letter C, and since this is the last one, and there were 2, you go true, false, true, false, true, false, true, false. And you now have all the possible truth values for that. So what you would then do is you would go through. And the idea is A, B, and C could all be true on one line, right? At the same time, A and B could be true while C is false. At the same time, A and C could be true while B is false. Or A could be true and B and C could both be false. At the same time, A could be false while B and C are both true. A can be false along with C while B is true. A and B can be false while C is true, or they can all be false. And that's why you need 8 lines, because that will then encompass every possible choice. And so what would happen is you would just come down this. True wedge true is true, true wedge true is true, true wedge false is true, true wedge false is true, false wedge true is true, false wedge true is true, false wedge false is false, and false wedge false is false. So that takes care of that. And we would then come along here and just, so we don't accidentally look back at that, we just go ahead and highlight it, right? And then what we're going to do is same thing here. Oops. Just go ahead and highlight it. And then we'll go true, wedge, true is true. True wedge false is true, true wedge true is true, true wedge false is true, true wedge true is true, true wedge false is true, false wedge true is true, and false wedge false is false. So you then come along here, we just highlight it. If you were doing this on paper, you put a box around it, and you wouldn't bother to X out this column or this column, because that shows me which were the last 2 you were comparing. And you're then able to look down and say, in some lines it's true, and in some lines it's false. So this would be a contingent statement. You could then come along to this one, which is A wedge B, wedge C, wedge D. You need 16 lines. Now I'm not going to do it because you wouldn't have to do it, but what you would do is you would make A true on 8 lines and false on 8 lines. You'd make B true on 4 lines, false on 4 lines, true on 4 lines, false on 4 lines. C, 2 true, 2 false, 2 true, 2 false. Go down. And then D would go true, false, true, false, true, false. And that's the way you would set that up. And that's the way you'll set up all these tables from now on. Now let's go ahead and come on down here and look at a couple of these. And these lines might be off just a little bit, but essentially we can come along here and we can do some of these. So let's say, like here, we have M, and Z. So in this case, we have how many unique variables? I'm going to take out that number because I'm not sure the numbers actually are correct at this point. I kind of moved some stuff around. I think they're off. So we have M dot tilde M wedge Z. So we have 2 unique variables. So 2 times 2 is 4. So we're going to need 4 lines. And this is 4, 5, 6 wide. So we just insert a table that's 6 wide by, actually we're going to need to go 5 deep. And the reason we're going to have to go 5 deep is because of the fact that we need the top line for tilde M, close parentheses, wedge Z. Now as we said, M could be true and false. So 2 trues, 2 falses. You then come over here, 2 trues and 2 falses. Since it's an M, you need to make sure it matches to the other one. You can't come over here and go, okay, well we did true, true, false, false, so we need to go true, false, true, false. Because in this case, how is M true on this part of the line and false on the other part? It has to be the same all the way across the line. And then Z would be true, false, true, false. What you do is you start off with the least powerful operator, which is the tilde. Tilde is in front of individual letters. And you just say if it's true, it's false, and if it's false, it's true. And then what we do, we just want to mark this so we don't look back at it, like I said. And then, oops. mark that. And then we come along here, and true dot false is false, true dot false is false, false dot true, and false dot true is going to be false, 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 false. So then we can come over here, and we can just highlight this so we don't look at it, right? We don't want to confuse where our I is. So we're going to compare now the one under the ampersand to the Z. And true wedge false is true, false wedge false is false. And we now know already that since on one line it's true, one line is false, it's contingent. But we'll go ahead and finish this true and then false. Okay? And then leave the other two where they are. That way we see what the last lines you were comparing, and they're done. Okay? So let's do another one of these. Yeah, let's do number 7. Okay? Or that's not actually number 7. Let's do this one. I, horseshoe J, triple bar, the other. So it's 1, 2, 3, 4, 5, 6, 7, 8 wide by 2 unique variables. So 2 times 2 is 4. So we're going to have to go 5 deep. So we're going to go 8 by 5, like that. We just put this in here. Tilde, I, wedge, J, close parentheses. So we have 4 lines, which means the first one's going to be true, true, false, false. Our next variable is going to be true, false, false. Now, I was true, true, false, false. So we need to make sure that we keep that matching. And J was true, false, false. So we need to make sure it matches. You don't want this one to be true and that one to be false. You need to make sure they match across the line. And then we go with the least powerful operator, which is this tilde. So it becomes false, false, true, true, because you're just negating this one. So highlight it or cross it out if that's what you're doing. If you're doing it on paper by hand, and just cross it out, just put a real thin line down it. And then we can compare I horseshoe J is true, true horseshoe false is false, false horseshoe true is true, and false horseshoe false is true. So then just mark these off, right? Make sure we don't look at them. And then we can compare these. False wedge true is true, false, true, true, right? True wedge true. Oops. And then we can just highlight these so we don't look back at them. And we're now comparing true, triple bar true is true, false, triple bar false is true, true, triple bar true is true, and true, triple bar true is true. And so we highlight that in yellow or put a box around it, and we now know that this one will always be true. And so we can label this one as tautologous. Simple enough. And you would then just come along and you can do this on every one of these. So, I'm trying to think of one, but this one is an example of something where they're always going to be true. You'll have cases where when you get down to the end, they're all going to be false, and there'll be somewhere some of them are true and some of them are false. And that's all it is. Now these truth tables at first are going to be annoying, and make sure to do it and sort of slog through it. But about the time you get to about your 20th truth table or 30th truth table and you've got everything memorized, getting it down pretty good, it's going to become a lot easier, and you're actually going to get really annoyed that it's taking so long. So, with that in mind, you know, just slog through it at first, and at some point you're going to go, oh my god, I just wish this was done. And that's when you know you're kind of getting to a good point.